Let's try and answer, or let's say find these missing angles. So we're going to be applying the circle theorems here. Okay, it's going to be very straightforward. Circle theorem. So there are different theorems for different types of questions. Now, if you look at this, we can see that this circle here is divided into two equal halves. Okay, so we have a line here. So this is your diameter. So remember that your diameter is the longest chord. Okay, longest chord. Then it divides your circle into two equal halves. So now we have a semicircle. So let's focus on this side. We have a semicircle. And that's where we're going to apply the semicircle theorem, which states that, so let's look at it. The inscribed angle in a semicircle is 90 degrees. And what's the inscribed angle here? I'll use a different color. This angle here. So whenever you have a semicircle, the inscribed angle is 90 degrees. That is awesome. Okay, so we know that we already know one angle automatically. As long as it's a semicircle, as long as this line here is passing through the center of the circle, okay, this line in red is passing through the center of the circle and dividing the circle into two equal halves, can apply the semicircle theorem. Okay, so but we're still looking for this angle here. How do we go about that? So we can just by looking at this, I can say that this angle, let me use a different color here, is 40 degrees. Why? Because I applied what you call the inscribed angle theorem. That's another theorem. So how did I get 40? Because this angle here is half of the arc, of the intercepted arc. So we know that for the inscribed angle theorem, okay, the inscribed angle is half of the central angle, okay, but it's also half of the intercepted arc. And what's the intercepted arc for this angle here? Just look at this angle, trace it out. Just trace it out. You can see it's kind of, this is the intercepted arc here. If there was a central angle for this, let's say this is the center of the circle, we'll have something like this as your central angle. This will be 80. And then half of 80 is still 40. All right, so let me just erase this quickly. Erase all the blues for now. Okay, so our intercepted arc, all right, which is here for this particular angle is 80. So the angle inside, that's the inscribed angle, will be half of 80. That will be 40. Right, so you can see we've just applied two theorems here. Okay, we've applied two theorems. We applied the semicircle theorem. We've applied the inscribed angle theorem, and we're almost done. So let me quickly erase everything first. Okay, so what did we get initially? We had, let me use black now. We had 90 degrees, and now we have 40 degrees here because this angle here, if you trace it out, if you look at the chords that form this angle, go out, take it out. What is the intercepted arc facing the angle? It's this one here, which is 80 degrees. And what is half of 80? 40 degrees. So that's how we got the 40. Now, if you look at this now, this is a triangle, right? If you take this out, this is a triangle. We have 40 degrees. We have 90 degrees. The sum of angles in a triangle is 180. So let's say this one, we don't know what this is. So we have 90 plus 40 plus whatever this is. It's supposed to give us 180. Okay, 90 plus 40, that is 130 plus something, should give us 180. We can move 130 to the other side. That is 180 minus 130. That gives us 50 degrees. So it means that this angle that we're looking for is 50 degrees. Okay, also I just put this picture here just to show that, you know, this line here is not a diameter, it's not at the center of the circle. You can see it's obvious that this is not a semicircle, so you cannot apply it in this kind of circle. And also, in some cases, they'll put, a dot to show you the center of the circle. Okay, not all the time, but sometimes you can just see it visually that, okay, this is a semicircle. This is not a semicircle, so I can apply this theorem or that theorem. All right, so that's just what it is about. All right, so what we did here was we applied the semicircle theorem. So as long as this is a semicircle, the inscribed angle is always 90. All right. So sometimes they won't say in this sem, they'll just draw a circle, maybe divide it into half, and then to have something like this. So automatically you know that okay, this is going to be 90 degrees, always, as long as it's a semicircle. So missing angle was 50. Okay, all right. So let's just do that again. So we have 90. Why? Because of semicircle theorem. This is 40 because we applied the inscribed angle theorem where, the inscribed angle is half of the intercepted arc. What's our intercepted arc here? This one that is 80 degrees. And then this angle here will be what's remaining. You subtract from 180, you have 50 degrees. So the triangle looks something like this if you take it out. 90, 40. Sorry about my drawing, I apologize. 50. Very straightforward. Let's go to the next question. All right. So we have a circle like this. Now they put the angles outside. Now, if this is 76, now we have 76, we have 45. We're asked to find COE, angle COE. So when you want to find an angle, you follow the letters they gave you. So we start from C. C is here. So COE. So we're looking for this angle here. Okay, angle COE. I'm going from C to E. I'm looking for this angle here. So how do we go about it? All right, how do we go about it? Now, we know that this is 76. So hold on, let me do a bit of erasing. Okay, this is 76. So sometimes they might put the angles outside. They might put the angles at the center like this. So this is also 76. Okay, so this is 45 degrees. But we don't know this angle now. Remember that this is a semicircle. Okay, this line divided the circle into two equal halves. So this is a semicircle. Okay, and what is the sum of angles the sum of angles in a circle is 360. So the sum of angles in a semicircle is going to be half of that, which is 180 degrees. Okay, now this is different from the semicircle theorem. Okay, this is what you're talking about the sum of angles, here. Okay, the sum of angles in a semicircle is 180. All right, so it means that all we just have to do is, first of all, we can find this angle here. Okay, so it means that let's say this is angle COD. Let me use a different color. COD. Okay, we're looking for angle COD. So it means that 45 degrees plus 76 degrees plus angle COD should give us 180. Okay, so 45 plus 76, so 5 plus 6 is 11. 4 plus 7 is 11, so plus 1, that's 12. So 121 plus angle COD is 180. We can move the 120 to the other side. So angle COD going to be 180 minus 121. Okay, so this is going to give us 9 and 5, 59. I presume 59 degrees. Yes, that'll be 59 degrees. So it means that this angle here is 59 degrees. So I've gotten one part done. Okay, so we still have to find this other angle here. Now, sorry. If you notice this angle here, okay, and this angle here, they're equal. Okay. I'm sure you've heard about vertically opposite angles, so like this, where they form like an X. So this angle here and this angle here are equal. While, let me use a different color. Let's say this angle here and this angle here are also equal. So these are vertically opposite angles, and they have, formed at an intersection. Okay, so if this is 76, this is also 76. So if we draw a circle like this, we cross them like this angle here. So let me put A, B, C, D. Angle A and angle B are equal. Angle C and angle D are equal. As long as they are facing themselves, they are opposite themselves. They call them vertically opposite angles. Vertically opposite, like they're directly facing themselves, like this. Okay, you can see these angles are facing themselves. So this is 76. This is also 76. So you can see we didn't have to do too much calculations. But I mean, we had to calculate 59, obviously. So let me erase everything and kind of um let me erase all this so it's now clearer. Okay. So again, let's go through it. This is 76. And because this is 76, look at this line. They are formed like this. They are vertically, sorry, they are vertically opposite. So this is 76. This is also 76 degrees. And remember that we got this as 59. So now we can get our COE by adding 59 and 76. So what is 76 plus 59? Okay, 76 plus 6 plus 9 is 15. So 15, 7 plus 5 is 12, plus 1, that's 135. So angle COE is 135 degrees. That's it. Okay, so let's go through it. We talked about, I'll just go through this blank page, sum of angles in a semicircle is 180 degrees. Again, then we talk about the vertically opposite angles. So example, let me use a different color now, like this angle A and this angle are going to be equal, while let's say this angle C and this angle D are also going to be equal. Okay. And what else? Let me see if we can add more information. Um, not much, not much, not much. Okay, that's it. That's just it. Okay, so we've applied. So what we just did was we need to know the sum of angles in a semicircle, and then we just apply this, vertically opposite angles are equal. Very straightforward. I'm gonna answer. Let me know if you have any questions. Okay, last one. Angles in the same segments. Now, just by looking at this, okay, by looking at this, these two angles are equal. Like what? Now, because first of all, if you look at, let's look at this angle first. Look at the chords that form this angle. Okay, coming from this. Okay, go down. Let's go down. Let's trace it here to point Q, down to point R. So the chords that form this particular angle, okay, are subtended from points Q and R. Now look at this other angle. Isn't it the same? If you trace it down, it also starts from point Q, point R. So they are called, so how do I say, these angles are formed from let's say from the same point, from points Q and R, okay? They are subtended from point Q, and you can actually draw a chord here from, say an imaginary chord here. Okay, this is one segment. So this is, I'll call this a minor segment. And this is the major, let me use a different color. Major segment, this big right here. So the angles in the same segment, they are equal. Okay, these angles are equal. All right, so look at, let me see. Sorry. Let me just go through it again. Here's our ink on slide. All right, these two angles, what's wrong? Yes. So this angle here, if you trace it down, you can see it's going to point Q and point R. Okay, so they are kind of subtended by the same arc. Look at this is QR. Okay, let's go to this point now, this angle here. Trace it down. The same arc. The same arc. They are subtended by the same arc. And then if you draw an imaginary line here, they're in the same segment. This is the minor segment, and they are both of them are in the major segment. They're equal. They're equal. This is the angle in the same segment theorem. So they are equal. They are subtended by the same arc. You know, same arc, the same points. Okay, they're just touching at different parts of the circumference. Now, even though you had something like this, so let me give you an example. Even though you had something like, let's say this point now, mm, it touches somewhere here. As long as it goes back to here, this angle is also going to be 46 because it's subtended by the same arc, QR, same points, and it's also touching a part of the circumference. They're the same. Okay, 46 degrees, 46 degrees. So these are the theorems I want us to go through for today, and it's quite straightforward. Yeah, very straightforward. So when you see something like this in an exam, don't be scared, don't panic. It's just they're the same. Okay, they are the same. Okay. Now, just in case, we, I mean, just by looking at this, so we can also say that, we can say that, wait, this angle here, just look at it, this angle here and this angle here are also equal, although they are not 46 though. Okay, because they are formed by this, they're subtended by this arc here. So which is totally different from this one. You can see this one is actually larger. This arc is larger while this arc is a bit smaller. Okay, so if you trace it like this, you see this arc here, this angle here, both of them are subtended by the same arc. So let's, for example, if this was, let's say, 25 degrees, this would also be 25 degrees. So you can see it works both ways. All right. So as long as you can see it with your eyes, see it visually that okay, these two angles, are subtended by the same arc, formed, from the same points, and then touching the circumference, they're equal. All right. So I hope this helps, and I hope I've been able to explain everything well. I'll be adding more questions. Have a nice day.